This is lesson 4.1, writing equations in slope-intercept form. Remember, our slope-intercept form is y equals mx plus b, where m is your slope, remember, rise over run, and b is your y-intercept. So our essential question here is, given the graph of a linear function, how can you write an equation of the line? So in our first example here, we're going to use slopes and y-intercepts to write equations. So it asks us to write an equation of each line with the given slope and y-intercept. Remember, we're just doing the whole y equals mx plus b. Slope, y-intercept. So with this information given to you, we have, for this first one, y equals, my slope is -3, so I just put -3x. My y-intercept is -1, so I just write -1, or -1. For our second one here, we have a slope, y equals slope of 0 times x, and a y-intercept of -2, so I put -2. Now to simplify this, 0 times any number just doesn't exist. So the equation of this would be y equals -2. How about our second example here? How can we do that using graphs to write equations? We're asked to write an equation for each line in slope-intercept form. Well, let's look at our first one here. It crosses the y-axis at -3. So we already know that our y-intercept is -3. Now the only thing we need to figure out here is, what is our slope? Remember, slope is rise over run. Here, we're at -3, and we go up 1, 2, 3, 4, 5, 6. So a rise of 6, and then over 1, 2, 3, 4. So rise over run is 6 over 4. Is that in simplest form? No, we could reduce that. So our slope here is going to actually be 3/2. Remember to go ahead and keep it as an improper fraction. It's best when we're dealing with slopes that you leave it as an improper fraction. So now to write it in slope-intercept form, we're just going to go y equals, my slope is 3/2 x plus our y-intercept, which is -3, so I'm just going to put -3. So our first equation is y equals 3/2 x minus 3. So let's look at our next one here. It shows that our y-intercept, which is where it crosses the y-axis, is right here at 2. So our y-intercept is a +2. Let's figure out our slope. We're given these 2 points, 0, 2, 4, -1. Our rise is 1, 2, 3. But notice, our rise is going down, so it's a -3. Remember, we always work from the left point to the right point when we're looking at slope. So we're going down 3, which is a negative, and then to the right, 1, 2, 3, 4. So our slope is -3/4. Is that in simplest form? Yes, -3/4 would be in simplest form. So our equation of our line is going to be y equals our m, or slope, which is -3/4 x, plus our y-intercept, which is 2. So the equation of this line is y equals -3/4 x plus 2. Now our third example here is what happens when we're just given 2 points and we're asked to write an equation. It says we've given these 2 points of a line that passes through the given points. How am I going to write that equation? Well, first off, we can look at this and remember, where is a y-intercept? The y-intercept is always going to be the point where the value of y when x equals 0. So if you notice, on both of these, we do have that point. Right here, x equals 0, and right here, x equals 0. So for A, our y-intercept, or B, is -1. For B, our y-intercept, or B, is -5. So now that we have our y-intercepts of both, all we have to do is figure out what is our slope. Now, if you remember, I know we haven't worked on it a lot, but our slope is rise over run, which is the change in y over the change in x. And remember, we can just take either points and consider them x1 and y1. So to find our slope here on A, I'm going to say that y2 is my -1 minus my y1, which is 5. And remember, so I said this is my 1s, this is my 2s. So x2 is 0 minus my x1, which is a -3. So to simplify that, -1 minus 5 is -6. And 0 minus a -3, keep change switch, is 3. Is that in simplest form? No, I could actually just make that a -2. So for my first one, for A here, we now have our y-intercept and our slope. So I can just write y equals m, which is my slope, -2x, plus b, which is a -1. So I'll just put -1. So that's what that first one's going to be. For b, we're going to find it. We're going to have, I'll just again say this is 1, this is 2. So y2, which is -5, remember, y is the second number, minus, so we're going to put minus a -5. And then x2, which is 8, minus x1, which is 0. Keep change. We have -5 plus 5, which is 0. And 8 minus 0 is 8. 0 divided by anything is just going to be 0. Now, it really matters where the 0's at. If the 0's in the top, it's okay. It's a 0 slope. If the 0's in the bottom, remember it's undefined. So to write our second equation, we're just going to have y equals my slope, which is 0x, minus 5. And remember, 0x, so I could just write this as y equals -5. Alright, let's try example 4 here. Writing a linear function. We're going to write a linear function. This time we have that whole funny f of x value written here. But it's saying write a linear function with the value of f of 0 equals 10. Remember, that means we have an x value of 0, a y value of 10, and f of 6 equals 34. And again, that's telling me that x is 6, y is 34. So really, all you got to do is take this function notation and figure out what it means as far as putting those 2 points. And it's really no different than what we've already been working on. So we already know the y-intercept, our b, is going to be 10, because remember, it's the y value when x is 0, and when x is 0, the function is 10, or the y value is 10, so b is 10. Now we got to figure out our slope. We'll call this one 1, this one 2. So we've got 34 minus 10, change in y, over my change in x, 6 minus 0, which is going to give me 24 over 6, which is just going to simplify to 4. Now, to write the equation of the line, we are going to have y equals my slope, which is 4x, plus my b, which is 10. Now, this is written in linear form, but if I wanted to write it again as in function notation, remember, the only change here is instead of writing y, you're just going to write f of x equals 4x plus 10. A linear model is a linear function that models a real-life situation. When a quantity y changes at a constant rate, remember, constant rate is a slope, with respect to a quantity x, you can use the equation y equals mx plus b to model the relationship. The value of m is the constant rate of change. That's going to be important. You're going to sometimes hear that interchangeable as slope being a constant rate of change. And the value of b is the initial or starting point, the value of y. So let's look at a real-life example here. Excluding hydropower, U.S. power plants used renewable energy sources to generate 105 million megawatt hours of electricity in 2007. By 2012, the amount of electricity generated had increased to 219 million megawatt hours. Write a linear model that represents the number of megawatt hours generated by non-hydropower renewable energy sources as a function of the number of years since 2007. And we're going to use that model to predict the number of megawatt hours that will be generated in 2012. Now, our first step here is to understand the problem. You know the amount of electricity generated in 2 distinct years. You are asked to write a linear model that represents the amount of electricity generated each year since 2007, and then predict a future amount. So we need to make a plan. Break the problem into parts and solve each part. Then we're going to combine the results to help us solve the original problem. So the first part is going to be to define the variables. Find the initial value and the rate of change. Remember, initial value is going to be my y-intercept. Rate of change, that's going to be my slope. So then part 2 is just going to be writing that linear model and predicting the amount. So to solve it, part 1 here, we're going to let x represent the time in years since 2007. And we're going to let y represent the number of megawatt hours in millions. Because time x is determined in years since 2007, 2007 corresponds to x equals 0. And 2012 corresponds to x equals 5. Because see, 2007 is going to be like year 0. And then 2012 is 5 years later. So we're going to have these 2 points. x1, y1 is going to be 0, 105. And my other point is going to be 5, 219. So the initial value, or our y-intercept, is going to be our 105. Now the rate of change, our slope, we're just going to find that by using these 2 points. Remember, to find our slope, we're just going to take that 219, subtract 105, then we're going to have 5 minus 0, which is going to be 114 fifths. Or in this case, we're just going to go ahead and put it as a decimal and make it 22.8. So to write that equation, we're going to have y equals 105, which is my initial, well, I'm just going to write my slope is 22.8 x plus my 105. Now, it's asked us, our part 2 here, to say estimate what it would be, let's see, in which year? In 2017. 2017 would be 10 years later. So we're just going to take our y equals 22.8, plug in 10 here for x, and when we solve that, we're going to get that y is 333. So that just is predicting that the non-hydropower renewable energy sources will generate 333 million megawatts in 2017. Get your notes finished up, bring them up for me to check, and get started on Clever.